Welcome, everyone, to the 16th CRC Roundtable. My name is Kelly Smalling, and I'm a research hydrologist with the USGS, and I'm joined here by Scott Phillips, who coordinates USGS science in the Chesapeake Bay. Before we begin, Scott and I'd like to thank Denise for handing the moderator reins over to us today. So hopefully we do her proud. For those of you that have not attended one of these roundtables before, the intention is to host targeted, inclusive, and informed conversation matching scientific advances and management needs. These webinars are really designed for contribution, not consumption, and each seminar invites a diverse range of researchers, managers, and other professionals to have conversations around critical topics to build connectivity between all of us and really increase our collective competency for decision making. As a reflection of that intent, the panelists, who I will introduce a little bit later, have been given about 25 minutes total to make some introductory remarks, and then we'll follow that by 30 minutes of facilitated discussion. This really is all about us. It gives us all a place to learn, discuss, and really think about and ask those clumsy questions. So don't be afraid, ask away. Next slide, Lauren. At each of these webinars, we've begun by answering the questions of why this topic at this time by these speakers. So why this topic? Per and polyfluoroalkyl substances, PFAS, which are also known as forever chemicals, have been manufactured and used in the US since the 1940s. They consist of more than 4,000 unique compounds, making them one of the most complex chemical mixtures out there to date. PFAS are and have been used as firefighting chemicals in consumer products such as water repellent fabrics, food packaging, nonstick cooking surface, as well as in industrial activities. In 2016, the EPA introduced the current non-enforceable lifetime human health advisories for drinking water for two legacy PFAS, PFAS and PFOA, and many states are also enacting their own drinking water standards. In October of 2021, EPA released its PFAS strategic roadmap, which is designed to consider the entire life cycle of PFAS from their unique properties, the ubiquity of their uses in everyday products, and the multiple pathways of exposure. This comprehensive strategy by EPA is designed to protect public health and ecosystems by researching, restricting, and remediating PFAS contamination. Why at this time? This topic is timely. Bay states are actively monitoring for PFAS. They also need information on occurrence and potential effects, as well as the Chesapeake Bay Program Science and Technical Advisory Council is hosting a workshop to gather state, federal, and academic partners to better understand the state of the science and improve science coordination on PFAS. The goals of this workshop include summarizing current understandings of the sources, occurrence, and fate of PFAS, identifying those current efforts ongoing, and those approaches to inform the potential effects on fish and wildlife, as well as their consumption, and considering study designs to compare sampling and analytical methods so that we can have a more coordinated PFAS scientific effort throughout the Bay. This roundtable is a means to introduce the topic, the workshop, and to communicate with a broader audience. So why these speakers? Our three speakers today each offer a unique perspective on PFAS and will briefly summarize some of the ongoing efforts focusing on what they have learned and what's next. Amy Williams is a water program specialist with Pennsylvania's Department of Environmental Protection's Bureau of Clean Water and will focus on ongoing efforts in Pennsylvania. Lee Curry is the Director of Water and Science Administration at the Maryland Department of the Environment, who will discuss work in Maryland on PFAS. And lastly, Betsy Beal is the Director of the Health and Ecological Criteria Division with the EPA, and will briefly discuss some of the information from the roadmap and describe EPA's efforts from a national perspective. And with that, I would like to thank you all again for joining us and handing the reins over to Amy.
Hi. Like I was introduced. My name is Amy Williams, and I work with the Bureau of Clean Water at Pennsylvania DEP. And I'm going to try here to share my screen. So bear with me. Okay. Can everybody see my screen now?
Yeah, it looks good, Amy.
Okay.
Yeah, Amy.
Yep, you'll definitely have to interrupt me because I can't see the faces now. To be warned when my time's coming. So just feel free to interrupt them when I'm close. In 2019, in coordination with USGS, we started to conduct a study to sample PFAS at all 178 water quality network or WQN stations in Pennsylvania. The water quality network stations are targeted sites that are sampled routinely for a number of compounds over multiple years to develop trends data, not just for PFAS. And sites are either kept long-term or rotated every 5 years. I'm going to go a bit over this study, but first, it's located here. So go to the DEP website, business, water, clean water, water quality, and CECs. Partway down the page, you'll see PFAS, and the data is located on the USGS website. And the summary part of the summary I'm going to show you is located here. So we sampled for 33 PFAS chemicals and 19 total oxidizable precursors or top chemicals. And the top assay treats samples to potentially expose PFAS chemicals that can transform into terminal PFAS compounds if they are present. Then the samples are retested for those compounds to quantify if any new chemicals show up. The table here, this is on that link that I showed you, shows the 33 compounds. And some information here, but I wanted to show you the maps. We also sampled at a select number of sites for long-term sampling using passive water samplers called POSIS. These are placed out for a month. And they're useful in order to see low-level contamination or contamination that may be occurring at a different time than the grab samples that we were collecting at the 178 stations. So you can peruse this at your leisure, but something that's pretty crucial to see is there's total PFAS noted here. That's the 7 compounds listed up above here, PFAS plus PFOA, the total PFAS in POSIS, and the PFAS plus PFOA in POSIS. And the highest concentrations generally are in the southeast corner of the state, the Chamonix Creek at Langhorne, PA specifically. So the second map here shows number of detected PFAS compounds in both the POSIS and the grab samples. And some items worth noting on this map is that you might see numerous low-level detections throughout the state, but it's so there are frequently sites that had up to 10 PFAS detected, but they might have been at very, very low concentrations. So just because you have multiple detects of PFAS at these sites, you didn't necessarily have high concentrations at all. And also worth noting is that there's actually, generally, we received more detections in the POSIS samples, the long-term samples, than in the grab samples, which is logical based on my previous explanation. So we've continued sampling, and these are not on the website as this is just preliminary data. However, on EMAP-PA, which is a public server, all of this data is available. So if you search for the sites, you can find all the data. We took a subset of the WQNs and sampled them again. And this first map shows the median of all detected results. So these were all the compounds that were detected. And the highest, again, is the southeast corner of the state. The second map shows the sum of all detected compounds, which there were 8 compounds detected, and separately PFAS plus PFOA. You can interact with this map and turn them on and off. So that's this current study. We're still working on finishing this up. This data set was downloaded in October. So I had a small presentation. Hopefully I don't run out of time here. But for the 2022 plans, we have a budget for 20 sites across the state in coordination with USGS again. And we'll be focusing sampling on problem areas. Just briefly, this is a lot of wording here, but I can always bring these up again if folks would like to read through it. But there's a fish tissue advisory on Neshaminy Creek Basin, including Neshaminy Creek State Park and Tyler State Park. That's our first fish tissue advisory for PFAS due to PFOS. The levels detected in fish tissue samples were over the 0.2 parts per million do not eat advisory level. That information is located here. And in the future, the department is going to sample more in the Neshaminy Basin above the dams to determine the extent of the advisory, and hopefully that will help with source tracking and allow PFBC to continue stocking the headwaters if it's fine. They're targeting other streams across the state and addressing some issues in how to preserve samples. So drinking water, they provided this update to me. The Bureau of Safe Drinking Water had a sampling plan to test public water systems that had the potential for elevated PFAS levels, and the sampling plan is located at the link here, and their results in table form are located here as well. So again, I can bring this up again for folks to copy down, or you can navigate to these by using buttons on the website if you drinking water, PFAS sample results.
About a minute left, Amy.
All right, perfect. So the last thing, and I'll leave this here, this is a link I took out of a media press release. So many people have probably heard about the EQB, the Environmental Quality Board, approving a rule to set the MCL for 2 forms of PFAS lower than the current to 14 parts per trillion for PFOA and 18 parts per trillion for PFAS. So far, that's where it's at. I pulled that off the website. That was November 16th, 2021. So I do not have any updated information on that yet. So that's what I've got. So it's great. I think I stayed in the time limit. Thanks.
Thank you. Excellent. So if you have some questions, put them in the chat, and we'll come to them after our other speakers. And
okay, I'll stop sharing here then. And
okay.
if anyone needs this up later, some of these slides for to copy anything down, just let me know.
All right. Thanks so much, Amy.
Stop sharing. Thanks.
All right. Nice job. So our next speaker is Lee Curry. Lee's the Director of Water and Science Administration within the Maryland Department of the Environment. So all yours, Lee. And right now, I'm not hearing you. If I see your slides. But
there we go.
There we go. All right.
All right. Can you see my slides also?
Yes.
Great. Fantastic. Thanks. And Amy, I really like that data system, the way you presented the information. Fantastic. So what I'm going to do is walk through where we are in Maryland, what we thought back in 2016, and most importantly, what we know today. I mean, if we look back to 2016 with the data that was collected at the time, there were approximately 40 water treatment plants that were sampled. There were non-detects found in all but one, and that one water treatment plant had levels below EPA's lifetime health advisory. So, in one way, we thought we were spared in terms of the potential PFAS challenges. But now you look ahead to 2019, 2020, and today, we see that's not the case. So we've definitely got more issues to deal with. One thing I will point to is EPA's lifetime health advisory for PFAS for drinking water and the toxicity information that goes along with that. We've been using that to provide context and make regulatory decisions. But I think an important piece of that is that EPA's recent effort, when they've submitted new information to the Science Advisory Board, has the potential to decrease those levels by more than an order of magnitude. So given while we thought we were spared before, we are seeing some concerns, and I'll try to bring those out today. And I'll cover a variety of issues and work that we've done. So if we look to the drinking water sampling analysis, we've collected about more than 500 samples over the last year and a half. Those samples were analyzed by our state lab, so I give a lot of credit for Maryland Department of Health for getting their state lab up and running and really being, our go-to lab for this type of analysis for PFAS. So of the 500 water samples we collected, more than 200 community water systems. What are we seeing? Well, if we look at EPA's lifetime health advisory as it is today with the 70 parts per trillion that Amy mentioned, we found 5 different water systems that had elevated levels. So previously we didn't see any, now we see 5. Those 5 have found alternate water sources based on our findings. So we've our efforts are to remove and reduce where we can the risk. Now, if we think about the direction that EPA is going with either a revised health advisory and MCL, those 5 water systems would now move up to about 35 different water systems. So it gives you a sense of the challenge that we face in front of us now. So right now we've got 5 systems that had elevated levels. We also have 11 systems that are continuing to monitor for PFAS because they did have elevated levels, but although they were below the health advisory level. So again, we could see that beginning to expand in terms of requirements for treatment or alternate sources moving from 5 to 35, or monitoring maybe moving from 11 to 100. So we can see the change. In terms of what we've learned from a science perspective, we tend to find the highest concentrations of PFAS in the western part of the state in groundwater. And given the karst topography, that's not surprising. We focused our sampling on areas where we thought there would be a pathway and a potential risk. So we looked at the possible number of sources, as well as unconfined aquifers and surface water. And we prioritized, all of our water system monitoring based on those criteria. And from a drinking water perspective, we're not finding elevated levels in surface water. In fact, all of our surface water samples were below 10 parts per trillion. So from a drinking water perspective, we're not seeing an issue there. So our elevated levels are in groundwater. We also looked at and sampled 11 reference sites that were mostly forest to just ask the question of, well, what would we find in those locations? And I think we didn't find anything. We found non-detect. So we thought that was important. And what that's telling us is that, there are areas where there's a risk, but the risk is not everywhere. So that was an important takeaway for us. Also, we're only detecting, we looked at 18 or analyzed 18 different compounds. And we're actually finding detecting 7 of them. And those 7 are consistent with the direction we see EPA going with getting more information from a toxicity standpoint so we can better understand if there's any health-related risks. So now let me move to the fish tissue sampling. And this isn't it's a mix of targeted monitoring as well as I would call responsive monitoring. We started in St. Mary's River, collecting data on oysters, trying to understand if there was an issue there. And that was really driven by a citizen's concern near one of our military installations. A citizen collected some information, reported high levels. We designed a pilot study and looked at sampled oysters and surface water throughout the St. Mary's River. And we also sampled a reference location, which was Fishing Bay, located over on the eastern shore. Within the river itself, of the oysters we collected, we did not find any detects in oysters. In our reference site, we found almost all non-detects except for one station. Did have one detection, but it was really at the limit of quantification for the lab analysis. So based on that, in the St. Mary's River, we said PFAS in oyster tissue does not seem to be a level of concern. And we then decided, well, using the resources we had, we decided not to collect any more oyster samples at the time, and we moved on to finfish. Now, when we moved to finfish, one thing that we found is, one, it was really challenging to find the funding to do the work. We had to scrape it together from multiple resources. We didn't have that, much like the drinking water was under the Safe Drinking Water Act funding. We didn't have the same level of funding for fish. What we did is, I think folks might be familiar with our mercury and PCB monitoring network. And we repurposed that network to focus more on PFAS, and recognizing that there would not be any significant health impacts as a result of not monitoring for PCB and mercury over the next few years. So with that, we've collected about 30 different information from 30 different locations, about 60 composites. We've done some targeted monitoring where we've collected fish tissue data downstream of another military installation that had elevated PFAS levels. And here's what we're finding. We're finding that there are elevated levels in some fish tissue, but not in others. So for example, we were at one location where we found elevated levels in largemouth bass and red breast sunfish, but we didn't find it in catfish. So we think there's some relation, and the fish scientists can tell us more about larger fish eating smaller fish. So it seems to be different than the way mercury or PCBs bioaccumulate. We also have posted one fish consumption advisory located in Piscataway Creek. Now, this was based on looking at toxicity information that is currently used for the current health advisory level. We did a projection and asked the question, well, with the information we have on better information on toxicity and the direction that EPA seems to be going, what would be the impact? Well, those fish tissue advisories would expand from one location. We think there are probably 5 or 6 different locations. So we see a challenge on the horizon there. Moving forward, we're also planning some additional efforts. Well, one on private wells to better understand the risks associated with private wells. And are we finding elevated levels, or what is the occurrence of PFAS in private wells? And this spring, we have a planned monitoring study to go out and collect information on blue crabs. The blue crab, and why we're collecting information on blue crabs was, prior to doing all this sampling, we formed I would say a science roundtable where University of Maryland helped us with it. And we presented our plan, asked them, were there any fatal flaws, any data gaps? And one they recommended was they didn't see blue crabs in there, and there was a lack of scientific information on that. So that was really helpful in terms of shaping our monitoring plan. So we hope to have more information in the future on that. There are several activities underway for managing sources in Maryland, whether it's looking at federal facilities and PFAS that's accumulating in the groundwater. We're not finding drinking water concerns, but we are finding some groundwater plumes that are, we believe, and data is showing that are heading towards surface water areas that could impact or bioaccumulate in fish tissue. So we're working close with the federal facilities on that. We're trying to move forward with wastewater treatment plant monitoring, looking at what's going in and what's coming out. We are receiving some pushback related to that from some of our municipalities in terms of moving forward with PFAS. But we're working through those details. We also have a survey that went out to 1,700 different industrial wastewater treatment plants to better understand if they are using PFAS in their process, or if they have any products on site, so we can better understand the sources. We've built in a way to collect information in one of our industrial stormwater permits And given that firefighting foam for training exercises was banned in Maryland, and that went into effect in October, we developed a lot of outreach material to help fire training centers, fire stations to better understand and manage PFAS within their operations. So, for example, if they have it on site, making sure they're not using it for training activities or actually finding ways to replace it with different chemicals. Partnerships.
We're about
have
at our
been
time, Lee, so if you can wrap up soon, that'd be great.
Yep, thanks. Do I have a minute?
A little less.
Oh, excellent. So partnerships are important, state, regional, local, stakeholders. That's been critical. Again, our work with all of our state agencies, we meet one time per month to really share all the information and go into take a deeper dive into what I'm presenting to you today. And my last slide. So we've made some substantial strides, I think, to really understand, manage, and communicate the risk. As I mentioned before, what we know now, there are elevated risks in some locations. It's not everywhere. And there are still some outstanding issues. And I see it getting more challenging as we collect more information and as our health advisory levels or regulatory levels become lower. We're going to have more challenges in terms of managing sources or fish consumption advisories. I have put a website on the bottom here, and that should provide you with much of the data, reports, information that I presented today. So thanks.
Thank you, Lee. And got a lot of good questions coming in, which we'll get to after our last talk by Betsy. So while Betsy's pulling up her screen, she's director of the Health and Ecological Criteria Division within EPA. She'll give us a little more of the national perspective. So all yours, Betsy.
Okay, just let me find my presentation and it should be good. Okay.
Yeah, if you can pull it full slide mode, we'll be good. There, looks great. All yours.
Can all see that? Okay, great. Hello, folks. There's an awful lot going on in EPA on PFAS. I'm going to try to summarize for you some of the major actions identified in the strategic roadmap. You can read that about that for yourselves at this website, cleverly entitled epa.gov/PFAS. So there's an awful lot going on. I'm going to try to cover just the highlights today. Just to let you know that the origin of the roadmap was from a request by our administrator to develop a whole of EPA strategy to protect public health and the environment. The EPA PFAS Council, which has senior leaders from across EPA, published that roadmap in October of this year. And there again is the website where you can go read more about it. As Kelly mentioned earlier, the goal of the roadmap is really to consider the life cycle of PFAS and to get upstream of the problem, hold polluters accountable, and enhance the science, as well as protecting disadvantaged communities. And I think you see that reflected in the roadmap. So the next 4 slides I've got, I'm going to spend the most time on. They're divided by different offices in the Office of Water, which probably doesn't interest you that much, but it's an easy way to organize this information. And so the Office of Chemical Safety and Pollution Prevention, which operates under the Toxic Substances Control Act, or TSCA, published a national PFAS testing strategy in October, pretty much simultaneous with the roadmap. The testing strategy requires manufacturers to provide toxicity data on 20 different categories of PFAS. So in order to develop this strategy, they tried to lump PFAS into various categories. The first round of toxicity data requests, as in test orders, are to be issued at the end of 2021. So that's shortly. There will be requests to manufacturers to send in data. Skipping to number 4 on this list, There is an enhancement of the toxic release inventory, which requires relevant facilities to collect and report information on 175 different perfluorinated compounds. So we'll have a better idea of where and how much of those compounds are used. And the last bullet on the slide, to finalize new PFAS reporting under TSCA Section 8. This is an interesting requirement for manufacturers as well as importers to report the identity of PFAS manufactured since 2011, as well as their byproducts, including categories of use, production volume, disposal information, worker exposure, and environmental and human health effects. So that's a fairly substantial requirement. A lot of the work is being done in the Office of Water. There's also an enormous amount of research going on in the Office of Research and Development. So I'll take a little more time on these slides. One thing you may have heard of is that there is a nationwide monitoring program, which is focused on collecting information on PFAS in drinking water. That's the Unregulated Contaminant Monitoring Rule number 5, was proposed in March. They'll be looking for 29 different PFAS at drinking water facilities across the country. And that rule is slated to be finalized very shortly. We are hard at work on a national primary drinking water regulation for PFOA and PFAS. The proposal of that rule is expected for 2022, the end of 2022. And as was mentioned earlier, there's a fairly significant milestone coming up for this tomorrow. Tomorrow, the EPA Science Advisory Board meets to provide us feedback on 4 documents that were developed as sort of approaches for the development of the drinking water regulation. 2 of those documents are updates of the toxicity assessments for PFOA and PFAS. And as Lee said, the values that we have identified based on new data published since 2016 are significantly lower. They're actually 4 orders of magnitude lower than the reference doses that were published associated with the drinking water health advisories. So a very significant change, the result of hundreds of epidemiological studies that were published since that time and have been formed the basis of the, were used quantitatively to identify new RFDs. There's also a summary of new animal data. There's been an explosion of information on both PFOA and PFAS since the original health advisories were developed. In addition to those 2 updated assessments, we've also published more as not as part of the MCL, but as associated risk management, a document describing how one might go about assessing risks from multiple PFAS when you're exposed to mixtures of PFAS. So the original health advisory suggested you combine information on PFOA and PFAS and compare that to the health advisory level. This document provides substantial science supporting that general approach and provides 3 different methods for combining multiple PFAS beyond PFOA and PFAS and assessing associated risks. Again, not associated with the MCLG development, but risk management.
1 minute left, Betsy.
Oh God. All right. So I'm just going to say there's a lot of work going on to develop additional tox assessments, health advisories for the 2 PFAS chemicals that we recently completed tox assessments for, as well as the updated health advisories. There's work going on to develop effluent guidelines for perfluorinated compounds. We've worked with the Office of Research and Development and the DoD to develop analytical methods. And if you have questions about that, I can explain more about that later. We're working to develop water quality criteria and hope to propose in the spring criteria for aquatic life. There is work going on to do national monitoring for PFAS in fish tissue. And we're continuing to assess risk for PFOA and PFAS in biosolids. I'm going to just skip to the last slide and just tell you a little bit more about the methods, because I think that might be of interest. In addition to targeted and non-target analyses, we posted draft methods for 40 PFAS in various media, including wastewater, surface water, groundwater, soil biosolids, landfill leachate, and fish tissue. Those are single lab validated methods, and stay tuned for the multi-lab validated methods. That's work going on with DoD right now. Other methods are available for drinking water and non-aqueous non-aqueous drinking water. I think that's through OLEM. Drinking water, there are 29 PFAS, 24 PFAS in the OLEM 1, and 50 in an air method that has been developed. And there is significant work going on also to look at air and exposure through that medium. And I'll stop there.
Thank you so much. And to all our speakers, great talks. We realize it's a lot of information to try to get across a very short period of time. So Kelly, I'll turn it over to you. I know we've got a lot of questions we wanted to try to address in the chat.
Yes, so I've been trying to go through the chat and jotting down some of your questions. Feel free to keep them coming. I will, if Lee could turn on your if you could turn on your camera, that would be fantastic. I know Amy's doesn't work, so I will try to get questions to each one of you from the chat. If we miss any questions, there will be material that'll be submitted to participants following this webinar. And many of the websites that I know Amy was hurriedly dumping in the chat, we'll pull those out and send them across as alternate resources. So first, I want to thank everyone for joining us. Thanking our speakers. I know 8 minutes was tough, but I appreciate everyone staying relatively on time. So we've got about 20 minutes, 22 minutes for some questions. So this has popped up a couple of times from a state perspective, and I know Lee's been answering questions in the chat, but I'll ask you to re-answer those questions. From a state perspective, for both Pennsylvania and Maryland, there was a question about biosolids and the analysis of biosolids and for PFAS and PFAS precursors. Have those occurred in your states? If they haven't, are there any plans to look at biosolids?
So I think I saw Lee's answer. We at DEP, Pennsylvania DEP, I know that it was mentioned under our PFAS action team about monitoring for biosolids for PFAS, but I'm not aware if that's happened yet. That's something I can check into.
Yeah.
I don't see anything out there yet.
In Maryland, we haven't collected any information, or I don't know of any information available for biosolids. We haven't included it in monitoring requirements in one permit for influent, effluent, and biosolids. This was for a federal wastewater treatment plant, and we have 15 municipal wastewater treatment plants that we're working with the municipalities on a PFAS monitoring program that would include biosolids. We expect that probably within the permits for the monitoring to begin sometime early next year.
Thank you both. kind of keeping with the biosolid theme, as well as kind of moving in, there was a variety of questions on analytical methods. I know this is a question that a lot of folks have. The first question, let's keep with biosolids. This was actually directed to you, Betsy, is what are the EPA recommended sampling and analytical methods for biosolids?
Well, I can't really speak to sampling, but the analytical method, there is this latest analytical method development activity that I mentioned does include biosolids. And so that's the one we'll be leaning on. It is a preliminary method right now. I'll have to get the link to it and provide it to you later, if that's okay. So it's been through a single lab validation and for use in Clean Water Act purposes, which is the statute that biosolids are regulated under. It needs to go through yet another stage, and that's in process right now. So I think it's less than a year away of having a final method. That's just my best guess, but they've been working hard on it. So I'll get the link to that method and send it to you for distribution.
Okay, thank you. On the related to methods, there was a question about, and this is for everyone. How many labs can perform these analyses? So from a state perspective, do you work with one lab? And then from an EPA perspective, do you have kind of a list of the labs that can perform these analyses? And do they engage in intercalibration or interlaboratory calibration? And does EPA try to conduct some of these calibrations, or do they work with folks to conduct some of these calibrations? So Lee, do you guys have one lab that analyzes all of your samples?
We work with multiple labs. Our state laboratory through Maryland Department of Health ramped up its capability for PFAS, and they've been analyzing all of our water samples, and they're participating in a national EPA study to, I guess, to verify or finalize methodologies for fish tissue, wastewater, biosolids, and others. We have, for our fish tissue samples, we've been sending those out to private labs for analysis.
Yeah.
What about? Thanks, Amy. What about you?
Sorry. Yeah, we've for our fish tissue, we have been sending it out to SGS Access in British Columbia. The same with the majority of our water samples before our lab actually was able to, for surface water, before our lab was able to actually do those. We do our surface water samples in our laboratory now. And I believe it's because it's working on being able to do biosolids and tissue. There are other laboratories we've seen that can do it though. I think PACE Analytical is coming to mind for solids, and a lot of other labs are starting to get on board, I think, with being able to do PFAS. We've been working with solely SGS Access or our laboratory. Can't speak for drinking water. It may say on their report, it would say on the report, I'm sure, actually, what laboratory they used.
And so I guess from a state perspective, is there a desire for labs to standardize methods so that, there's, from a comparison across state lines, state boundaries?
Well, mainly they have been using EPA methods. The EPA is like drinking water methods. The surface water before that was actually approved. There was a SGS Access uses a like a proprietary kind of method, but they work a lot on developing methodologies. So
I think there's a need in terms of what EPA, Betsy mentioned earlier, with EPA finalizing their work on methods development, and through that work where information is being sent out to multiple labs. I think that's going to help move things forward. When we issued RFPs for our lab analysis for fish tissue, we did not get a lot of responses.
Betsy, do you have any insights into, lab methods, intercalibration, how EPA can kind of move this forward and help kind of, I don't know, standardize or make sure that we've got results that are comparable?
Yeah, that is exactly the effort that's going on right now. It's a multi-lab validation method. And so what that means is that a number of different, it's trying to make sure that that the ability of different labs to run the method is consistent and achieve certain standards. I've got the link to the EPA method, and I'm going to put it in the chat. So right now the multi-lab validation effort is ongoing.
Okay. Thank you. One other question is related to, is NELAC accrediting labs to PFAS methods? Does anybody know?
I don't know the answer to it.
Okay. And one other question related to methods is related to asking if EPA is monitoring certified labs for accuracy of PFAS analysis. And which office at EPA do folks contact if they've suspected that there's inadequate PFAS testing to the public? We've suspected case of marketing inadequate PFAS tests to the public. So what office of EPA works with the laboratory validations?
That would be my office. In the Office of Water, it's the Office of Science and Technology, the Engineering and Analysis Division is responsible for that.
Thank you.
Moving away. Follow-up to, just real quick,
sorry.
a follow-up to that was, with our STAC workshop coming up, we'd really like to interact with you to make sure we're taking advantage of the different offices in water for our PFAS workshop, from methods to analysis, et cetera. So we'd definitely like to be reaching out to you on that. Greg Allen, who's on that committee, had a comment along those lines.
Moving away from analysis and to treatment, there was a couple of questions in the chat related to treatment. So the first question, and I think Lee, you answered this, but what options do we have for treating contaminated water, PFAS contaminated water?
Sure. In the chat, I put 3, which are granular activated carbon, has been successful at reducing PFAS levels, as well as ion exchange and reverse osmosis. And that's been for drinking water. I think there might be, additional challenges on, what do we do with wastewater? I don't have an answer for that.
And as a follow-up to that, the question is really, I think it's related to the EPA's benchmarks, but what's the level of interest for removal? So when do you start talking about, from a state perspective, when do you start talking about removal or treatment?
So in Maryland, we used EPA's health advisory level of 70 parts per trillion, which we believe is going to be going down to a lower number. And we required the 5 different treatment plants or areas that had elevated levels just to find an alternative water source. Many of those they were able to either blend water or pump from a different location or shut off wells. But there are going to be areas where that's not going to be an option, and treatment will be needed.
Amy, do you have any thoughts on treatment, or is there anything that Pennsylvania has done or has had to do based on your PFAS levels?
I don't have anything above what Lee's already said.
Okay, perfect. The next, one of the other questions is related to fish tissue. I know, Lee, you mentioned catfish having lower levels than some of your bass. One of the questions was, were there estimates of age on each of the fish? Could age be one of the drivers of contamination?
Yeah, I don't know. I don't know. I could follow up with that
Okay,
possibly.
Yeah, so I could follow up with that as well. I actually was asking our fish tissue expert here. I'm sure that they actually do notate the age as an age estimate, and I think that they were sampling fillets, but I can verify that.
okay, thank you. And the other question related to fish tissue was what part of the fish are you sampling? Is this fillet? Is it from a consumption perspective? Is it whole body? Is it other tissues, plasma?
So this is Lee. I'll check on that just to verify, but I thought it was fillets and then it was composite samples blended together. But I can double check and verify that.
What about in Pennsylvania, Amy?
Yep, that's I need to verify with our monitoring staff, but I think it's fillets.
And then for Betsy, same question from an EPA fish perspective. Are y'all focusing on the fillets?
Yeah, it's edible tissue. So
Okay, so predominantly focused on human health and consumption advisories.
right.
Okay.
Anyone from MDE is on the chat that collected data, they could answer in the chat.
We can also follow up in our email.
Yeah.
And so we're one of the other questions was really focused on kind of your monitoring, the state monitoring programs, and asking questions about how much does Pennsylvania and Maryland budget for PFAS monitoring and study, as well as for regulation of PFAS. And do you think, and this I'm going to add to it, and do you think this is going to change in the next couple of years?
So I guess I can chime in for that. I'd have to go back and get our estimate from our Safe Drinking Water Act program. What I can say is that the drinking water samples came out of federal funds, so we had the money to be able to collect quite a few samples. We had to scrape together money, and fortunately, we were awarded a grant by EPA for some of the fish tissue work. And as I mentioned, we repurposed our mercury and PCB network. But I also think, over the next 5 years for the bipartisan infrastructure bill, there are buckets for both in clean water and or let's say surface water and drinking water for contaminants of emerging concern. So that may be a possibility in the future.
What about Pennsylvania?
Yeah, I can't venture a guess at the budget.
Okay. Amy, really quick question. There was a question about your surface water monitoring. Do some of the sites include military bases?
Yes, some of them do. Not every military base in the state was included because the water quality monitoring network was is a fixed set of locations, but a number of them were included. Yes.
Okay. Before I get to one of the big questions that I'm going to ask everyone, there's a question in the chat about sources of funding for localities. Does EPA or other federal agencies have sources of funding for localities to study PFAS? Are there RFPs that localities or nonprofits could apply for?
There is under the Build Back Better Act, there is this substantial amount of funding for remediation activities at different facilities like drinking water facilities as well as wastewater facilities to address emerging contaminants. And I think people envision that as being a source of funding to deal with PFAS contamination.
Okay, thank you. So one of the questions, this is kind of a big question, and I'll open it up to all the presenters, but with so many sources of PFAS, how much focus is or should be on exposure prevention for people during our daily lives and people working in production industries versus contact with water and or consumption of animals exposed to contact with water. So basically, how should we prioritize where we're being exposed, why we're being exposed, and how we're being exposed in our studies and in our research and monitoring versus consumption? I mean, you've got
can
drinking
take
water
it.
and fish. Go for it, Betsy.
Yeah, just a first stab at that question, because that's a very big question.
Yes.
Is that in the work that we did that's going to the Science Advisory Board tomorrow, we tried to articulate different sources of PFAS. There's a term that's used in calculations of health advisories. It's called the relative source contribution term. So the two major sources, same as in 2016, were identified as food and dust. So a greater source of exposure than drinking water, which is why the relative source contribution term was set at its lowest level, because as you point out, there are substantial other sources. So that's just some information I would offer on the relative magnitude of some of those sources.
I also
And
think,
so- Yeah, go ahead, Lee.
go ahead.
No,
No,
no.
I was just going to say, this gets to risk communication also, which is really important for this issue, and a challenge that I believe we face and will continue to face. We've looked at, we've tried to communicate risk from a water perspective, recognizing that, as Betsy said, the relative contribution for the health advisory level, I think it was 80% of your exposure was assumed to occur from other sources when the drinking water health advisory level was developed. But it's also important to understand fish tissue, and you asked a question about swimming or contact, and we've been communicating that contact, there's not an issue related to a dermal pathway. And with swimming, we would be looking at accidental ingestion. And we did some analysis to determine that based on the levels we're seeing in natural waters, that would not be a concern based on current toxicity information. So I think kind of walking through them from the water perspective, it comes down to drinking water, which everyone is exposed to on a daily basis, or fish tissue, which is a smaller population.
Thanks, Lee. So we're getting close to 1 o'clock, and I'd like to ask each of the panel members for one, short parting important point that they really want to leave the audience with, whether it can be based on the discussions that we've had, based on your presentation, or just your own personal viewpoint. So I'd like to open that up. We'll start with Betsy, and then work to Amy and Lee. Just one thing you'd like to leave folks with.
Well, I guess the thing I'm struck by is that there's so much that we don't know about this full family of compounds, but there's a lot that we do know. And I think it's going to be really challenging. It will be very interesting to hear what the Science Advisory Board says about what we're saying about the potential risks of these compounds. So that's my takeaway.
Thanks, Betsy. What about you, Amy?
Yeah, we are definitely, Pennsylvania DEP is working on this. So no, don't fear that. In the future, we will be as well. And we're working on trying to find source tracking and solve some of these problems. Also, the 2019 data, I didn't mention before, we are coming out with a paper in coordination with USGS that will hopefully address some possible source tracking using that data. So that should be sometime in 2022, we hope.
Excellent. Thank you, Amy. Parting words, Lee?
I would say that we need to continue to follow the science. It's going to be really important, the information that comes out of EPA. We've been fortunate that we have, as Betsy said, we do know a lot. We've collected a lot of data. And I think we can use that information in combined with information that's coming out of the Science Advisory Board to better identify where there are concerns. Where there are concerns, communicate the risk, and then manage the risk. And basically, what's the best approach for protecting our citizens?
Excellent. Thank you, Lee. And with that, I'd really like to thank everyone for joining us today and asking some really great questions. There's a survey that's in the chat. Please respond to that and expect an email with a lot of information from your speakers shortly. Again, thank you so much, and we'll see you next month. Back to Denise and others.
Thank you.
Thank you, speakers.